Section 5.5, Problem Solving with Methods. A large, complex problem can be solved one piece at a time with methods. Let's take a look at an example. In this example, we'll have three classes. A crate class, which defines a crate object with a length, width, and height, as well as a cost, which is what it costs a company to produce a crate, and a price, what a customer will pay for the crate. And the cost is 33 cents per cubic foot for the company, and the price for customers is 50 cents per cubic foot. Here we have in the crate class some variables that each crate object will have. These are known as instance variables, variables that an object carries with it throughout its lifetime. Every crate object will have its own length, width, and height that will carry with it throughout its lifetime. Next, we have some methods in the crate class. The methods are the first methods in the crate class are setters and getters, or sometimes known as mutators and accessors. So setters are also known as mutators because they change data, and getters are also known as accessors because they simply access data or retrieve it, but they don't change it. So for each of the instance fields length, width, and height, we'll have a setter so that we have a method to change that instance field if we want to change the length, width, or height of a crate, and also a getter for each of the instance fields so that we can see what the length, width, and height is for a particular crate object without changing it. The setup will be similar for all of our setters and for all of our getters. For our setters, the method name will start with set, and that'll be followed by the name of the instance field that we're going to change with it. So let's start with set length. And the setters will take in an argument that corresponds to the data type of that instance field. Well, all of our instance fields are doubles. Length, width, and height are all doubles. So our setter is going to take in a double. Let's call it L, and it's going to assign L to that instance variable length. Nothing's returned, so it is a void method. And here, let's go ahead and declare it as public, because we'll see that we'll want to call this method in a different class later on. Here's our getter or accessor method for that length instance field. The getter method starts with the word get for the name, followed by the instance field, so this one is for length, and the parameter list is empty. Why would that be? Well, unlike the setter methods where we're going to be changing a value, and we would therefore have to know that value that we're going to change the instance field to, for a getter method, we don't have to provide any information. We're just going to retrieve the length, but we're not going to specify what the length is. So we only need an empty parameter list. However, our return type is double. So why would that be? Well, unlike the setter methods, which are going to update a value but not return anything, the getter methods are not going to update any values, but they are going to return a value. So the double corresponds to the data type of length, and get length is going to return a double. In fact, it's going to return the double that is represented by length. We can take a look at the set width and get width methods. This is our setter and getter for the width instance field. Set width takes in a double called W, and it updates that instance field width with that value of W. Doesn't return anything, so it's a void method. And let's make it public so we can call it in a different class as well. Get width, just like get length, has an empty parameter list, a return type of double corresponding to the data type of width, and this method is just going to return that instance field width. And then the pattern continues for set height and get height, our mutator and accessor method for the height instance field. Okay, so those are our setters and getters. And that's a pretty common set of methods to include in a class's public interface, so its list of public methods. Then we've got some other methods defined in the crate class. For every crate object, we want to be able to calculate its volume. Here's our definition of a calculate volume method. It has an empty parameter list, it returns a double, and it's declared public, and it's just going to return the length, which is going to be retrieved using the getLength method, times the width retrieved with the getWidth method, times the height retrieved with the getHeight method. So all those are multiplied together, and the result is returned. Our next method is cost. The cost method doesn't take any arguments, but it has a return type of double that's going to represent the cost for making this particular crate. And the cost for making a particular crate is going to be the volume, so we can use the calculate volume method. So that's kind of neat to build off the methods that we've written and kind of apply them later on. The calculate volume method will tell us the volume in cubic feet of the crate, and so if we multiply that by the cost that was defined earlier as, I think it was 33 cents per cubic foot, then that'll tell us how much it costs to produce that particular crate. So that's the cost method. The price method, very similar. It's going to tell us how much this crate will sell for a customer. So the price method has an empty parameter list and a return type of double. It's declared as public, and it's going to return the price per cubic foot, so that was 50 cents, times the volume, and the volume is found using calculate volume. And finally, our method for profit. It's going to return a double, and the way that that double is going to be calculated is to take the price using the price method from above minus the cost using the cost method from above. So here we've really broken the problem down into smaller pieces with the use of methods. Here's our crate test class. This is going to allow us to, well, the idea is this is a driver class. And a driver class is a class that has a main method, and it creates objects of another class. And calls their methods. So that's what's meant by a driver class. And you might have noticed crate did not have a main method. So in crate_test.java, let's go ahead and let's write a main method, and let's actually use our crate class and call some of its methods. So here we can see that crate_test.java is a class, and it has a main method. And let's represent two crates. One that is 6 by 10 by 12, and one that is 14 by 3 by 5. So for the first crate, the 6 by 10 by 12 crate, let's make a new crate object using our constructor. So crate our crate equals new crate. And then let's call the setter methods to modify the length, width, and height. Let's make the length 6, the width 10, and the height 12. These would all be 0 if we didn't use the setter method to update them. When we create that new crate object, all those instance fields would just be initialized to 0. So let's make sure to set them to 6, 10, and 12 for length, width, and height. For the second crate, the 14 by 3 by 5 crate, let's make a new crate object. Let's call it rcrate2, and then let's use the setter methods to set the length, width, and height to 14, 3, and 5 in that order. Down below, we'll display the volume, cost, price, and profit for the first crate. For the first crate, we'll print out its dimensions, and taking the place here of these format specifiers, %.2f is going to be rcrate.getLength. Taking the place of this, and then we'll just see the x for times, like the dimensions, this by that by that. And then we'll see this format specifier, %.2f, replaced with rcrate.getWidth, and then by, times %.2f, which will be replaced with rcrate.getHeight. So that'll show us our length, width, and height for the crate. And they'll just have an x in the middle. And then let's print out the volume. So to print out the volume, we'll have a format specifier, %.2f, and so we'll print out the volume to 2 decimal places, and the volume will calculate by calling rcrate.calculateVolume. The cost, let's also print out to 2 decimal places with this format specifier, %.2f. Replacing that will be the return value from rcrate.cost when we call that method here. And then how about for price? Well, here's our format specifier, %.2f, and what's going to replace it? rcrate.price. For the profit, our format specifier, %.2f, is going to be replaced with rcrate.profit. So those are our calls to so many methods: get length, get width, get height, calculate volume, cost, price, and profit. And notice those are all being called on rcrate, which is that first crate that we declared. And so we could say that we're calling these instance methods from the crate class on this instance of a crate object, rcrate. Then let's do the same thing, but for the second crate. Let's call its instance methods, or let's call the instance methods for the crate class on rcrate2. That was the second crate we created, and we can see the pattern's the exact same here. So I won't, step through it in that same level of detail, but if you just want to take a look at the method calls here, we can see the same methods are being called, but they're being called on rcrate2. So we're going to call these instance methods on rcrate2, which, if you remember from earlier, we had set the length, width, and height to something a little different from rcrate. Okay, so let's go ahead and run this program. So I'll copy it into NetBeans. Okay, so I just made a new project called General Crates, and let's go ahead and I'll just copy the code for the crate class. And it looks like earlier I had named this package crate, but this time I named it General Crates, so I'm just gonna change the package declaration to General Crates. And this default file name was generalcrates.java, but let's change it to just crate. Okay, so there's our crate class. And then I think this is the first time that we've done this in the same project to have 2 .java files. So to do that, we're in the crates package. Oh, I'm sorry, we're in the general crates package. So better go up to that. General crates, here we go. And where you see the general crates package on the left in the projects window, if you don't see the projects window, just go ahead and click Window Projects. And then in the projects window, just right-click General Crates, that package name, and this is supposed to be an icon of a package. And then if you right-click and select New Java Class, then we can add a new class called Crate Test. And I'll just leave the other defaults and select Finish. And then for Crate Test, let's go ahead and get our code for that particular file. Crate Test. And I'll just paste it into that new file, and we can see that the package declaration is still as crate, so let's just change it to general crates. It looks like everything else is okay. So let's go ahead and run this program. Now, which file do you think we should run? Crate or cratetest.java? Well, we want to run the file with the main method in it. So that would be cratetest.java. So I'll just right-click cratetest.java in the projects window and then select Run File. And here we can see the output. For the first crate, the dimensions are being printed out as 6 by 10 by 12, the volume 720, the cost $237.60, the price $360, and the profit $122.40. And if we do a quick sanity check, I think the price was 50 cents per square foot, or I think this should actually say cubic foot. But the price was 50 cents per cubic foot, and so the price of $360 for 720 cubic feet, that does seem correct. Yeah. And then for the dimensions for the second crate, 14 by 3 by 5 for a volume of 210 and a cost of $69.30, a price of $105, so that looks right, half of the volume, 50 cents per cubic foot, and then the profit, that looks about right too. So the only thing I wanted to change was in cratetest.java, let's just make sure we're printing out the right units. So instead of square foot, that we're printing out cubic foot there. Okay. Let's go ahead and run it again. Okay. So just to summarize before we conclude, in this example we created a Java program with two classes, crate and crate test. The crate class defined a crate, and it had the instance fields of length, width, and height. And then we also defined a bunch of methods, some getters and setters for the instance fields, as well as methods to calculate the volume, cost, price, and profit for any particular crate object. Cratetest.java was a driver class. It had a main method, and it created objects of the crate class. It created two objects of the crate class, rCrate and rCrate2, each with their own instance fields that corresponded to the dimensions of those crates, their length, width, and height. And then we called the methods that we had defined in crate.java to find out the lengths, widths, heights, costs, prices, profits.